Hey guys, Oric here again to do the second half of the first half of the practice final. In other words, questions 11 through 20. I'm going to break each half up into quarters just to make the videos a little bit shorter. So we will start here with question number 11, and I'll post all of these up on our classroom page so you have them. So question number 11, this one should be fairly straightforward if you have the note sheet on switching from logs to exponents. Question 11, if just remember log A of C equals B, and it's what we use to solve for exponents, and we can go from exponents to log. This is the same thing as A to the B power equals C. I always like to think of it in terms of log of 100, which when you do log on the calculator, it's log base 10 equals 2. So if you try to remember that, then you can always switch it back and forth. 10 to the second power equals 100. So it's just a way for you to remember it without the formula. So this is 5 to the 0 equals x. And don't put 0, because you know that's going to be one of the answers on the multiple choice. 5 to the 0 power, any number to the 0 power is 1. X equals 1. All right, question number 12. In Anoka, population is 18,000, growth rate 3.5%. Just remember 3.5 and 2.1%. 3.5% is 0.03 is 3%. So 3.5% is 0.035. And 2.1% is 0.021. So in Anoka, we actually have growth, and the growth rate is 0.035. We started with 18,000, and we have a 3.5% growth rate, so 1 plus 0.035 for 20 years. And that equals 35,816. And in Minneapolis, the population's declining because they're moving to places like Anoka. And the population is 350,000. I think on my answer key I put 35,000. It's 350,000. And we're declining at a rate of 2.1. So 0.021 for 20 years. And that equals 228,940. And then be careful that you read this closely. If you read it, how many more people will live in Minneapolis compared to Anoka? So it's 228,940 minus 35,816. And you come up with an answer of 193,124. All right, question number 13. Asymptote and range of the following function. This graph, let's undo that there. I'll put a line down, make a little graph. And at 0, 3 to the 0 is 1. We're at -3. -1, 2, 3. And this is an exponential function. This value here is never going to get, if once x gets really, really small, like -1,000, when we get way out here, -1,000, that's 1 over 3 to the 1,000th power. So it basically goes to 0. So this graph is never going to go below -4. So at -4, we have an asymptote that kind of goes like this. And the graph is going to look something, and it's going to go up fairly steeply. Because of this too. So from our transformation chapter, it goes up twice as fast. It's got a stretch factor of 2, no shift to the left or right. So from our the graph of 3 to the x power, that would look something like this. I'll put that graph right here. It's going to look something like this. That's 3 to the x. This one drops that graph down -4, and it should be going up steeper. So what's the asymptote? It's at y. This is y equals -4. That's the asymptote. And the range, it'll never hit -4. So this part of the graph will never equal 0. It'll get really close to 0, but it will never hit exactly 0. So it's going to get really close to -4. So the range, what y will equal, will always be greater than -4. That's the range. Which of the following are exponential decay? So this is, unlike that question just previously there, all of the graphs are going, that's an exponential growth, whereas x gets bigger, y gets bigger. So what you're looking for is negative exponents, like a positive number, like the number 3 to the -4 power. That's going to, or the negative x power, that will decay. Negative exponents or fractional coefficients. And when I say fractional, I mean less than 1. So like if this growth factor r is less than 1, or between 0 and 1, then we're going to have a decay. If it's a negative number, then it's gonna come up from, it's gonna flip over the x-axis. So this is going to be growth. Oh no, that's going to be a decay. Sorry, ooh, my bad. Let me put a different color here, red. So this is 2/3. So that's going to be less than 1. So that's going to be decay. The 3x doesn't matter. 3x and the x would be the same for positive numbers. It's just going to be a little bit, the graph's going to shift a little bit, but it's not going to be different. This is greater than 1, so this is a growth. And sort of like this, 3x, 0.5x does not make it decay. So with the number 2, that's going to be a growth as well. So those first two are growth, or that's a growth. The only one that's a decay is this last one here. Okay, question number 15. We have what percent increases the following graph? This is really kind of a tricky problem, and it, if it was linear, you can kind of tell the slope that we're going up over 2 to the right and up 1. Let's see, this is 2, 1. No, that should be 1, 2 on the graph. That looks like the point 1, 2. Oh, sorry, guys. Hopefully I can correct my answer key. No, actually I can see on I redid that. So actually that's the point 1, 3 on the graph. 1, 3 on the graph. So it looks like the graph just shifted up to, so one way to look at this, if I look at my x and y, and I have the point 1, 3, and we started at 0, 2, our growth, how much we increased, we went from 2 to 3, so we went from 3 equals 2 1 plus the rate and the amount of time we went over 1. So we just, think of our x-axis as t. We divide by 2, that would be 3 divided by 2 is 1.5 equals 1 plus r. And then r equals 0.5. So this graph looks like it's 1.5 to the r, and then we have some number out in front. I'd have to take a look at the 2 times 1.5 to the r, because at 0 we'd be at 1.5. Sorry, should have worked this out ahead of time. But it looks like our growth rate at least is 0.5. When we can check that out, if I did 6.75 equals 2 times 1 plus r to the 3, 2 times 1 plus r to the 3rd power, r equals 0.5. So we're growing at a rate of 0.5, but that's really a tricky problem. I'm trying to think of a better way to explain that. If I think of something, I'll mention it in class. Let's go on so I don't make this video too long here. 16. Oops, go back. I guess I got to scroll down. 16. We bought a car for $10,000 after 2 years. So what we need to do is figure out our depreciation rate, and then once we know the depreciation rate, plug that in for 6 years. So if we have a value of $77.44 after 2 years, that's our new value, is equal to our initial value, 10,000, and 1 minus whatever our depreciation rate is for 2 years. So the next step is to divide by 10,000 and divide by 10,000. I know that's small. And that equals 0.7744. 0.7744 equals 1 minus r to the 2nd power. And then to solve for that, take the square root of both sides to get rid of the square root. And we have, I'm going to scroll over to here, square root of 0.7744 is 0.88 equals 1 minus r. And if you solve for r equals 0.12. So that's our depreciation rate, 12%. We're going down every year. Now the question is, what's the car worth in 6 years? So the amount the car is worth, here we knew that what the car was worth was $7,744. Now we don't know what it's going to be worth after 6 years. So our amount after 6 years is going to be equal to our starting amount, 10,000, and then 1 times 1 minus 0.12, or in other words 88%, to the 6th power. And if you just plug that in, 10,000, 1 minus times 0.88 to the 6th power. Let's go ahead and do that. Hey, do you like that, Oric? 10,000, clear. 10,000, 0.88 to the 6th power. 4644. Now this might be one on the multiple choice that you can kind of guess what the car is worth. I don't know what the values are, but at 12%, we're down below half after 6 years. 17, we want to look at these 64 and 1/4 are all, we can put in as the same base. 1/4 is 4 to the negative 1 power. All right. Hey, sorry, had just another interruption there. So 1/4 is 4 to the negative 1 power, and 64 is 4 to the 3rd power. And so we take that 3rd power, and then it's times 3x plus 2. So that's the trick with this question, is to recognize that 1/4 and 64 are both factors of 4, if you will. Plus 2. I don't think factors of 4 is the right term, but I think you get what I mean. So now 4 to this power equals 4 to this power. So the two powers, the two exponents have to be the same. So we can just get rid of the 4's. So negative 1 has to equal 3 times 3x plus 2. So make sure you distribute the 3. So that's 9x plus 6. And then subtract 6 from both sides and get 9x equals negative 7. And then our final answer is negative 7 over 9. X equals negative 7 over 9. That one looks like a fairly easy problem, but that's really not a very, very easy problem. Now this 18 is really not too bad. This is the log A of C equals B, or A to the B equals C. So 3 to the 4th equals 2x. That is now this is how it's worded on the final. In reality, this should be in parentheses, really, because this could be log base 3 of 2 times x, but this is what they mean. And then just divide by 2. So 3 to the 4th is 81, and then divide by 2. So 81 over 2 is going to be our answer. 3 to the 4th is 81 equals 2x, and x equals 40.5, or 81 divided by 2. All right, I'm going to do 2 more. Coffee. Here's the formula. It's an exponential growth formula to find out the coffee after so much time. And it's why we use logs, is when we have a variable in the exponent that we're going to have to solve for, because we're going to have to calculate the length of time. So initial temperature is 22 degrees, that's A, and the final temperature is 100. So our final temperature is 100 equals 22 times 2. Could graph this too and see where that intersects, but would that work? Yeah, well, we could see where 22 times 2 to the 1.6 t actually hits 100. 1.6 t. And then divide by 22. Let's go a different color. We'll divide by 22. Divide by 22. And what's 100 divided by 22? 100 divided by 22. 4.545. 4.545 equals 2 to the 1.6. Oops. 2 to the 1.6 is in the exponent t. And now we got to do log. Log A of B equals C. 8. Now here we have 2 is A. A to the B equals C. Log. So I'm going to do I'll do it on this side. So on this side, log A is 2. Log base 2 of C, B, or C. A to the B equals C. So C is our 4.545. Equals 1.6 t. wrote that kind of fast. And then, now to do this on your calculator, you got to do log of 4.545, change a base, divided by log of 2. And I'll show you what that is. Now this calculator, actually I can put in log base 2. Alpha log base 2, and I'm going to put this 4.545. That was my answer from the last one, so I get the exact answer. Second answer, 2.18. And but if you did log of, and so I get the exact answer of 100, clear. Yeah, 4.545 was 100 divided by 22. So if I did log of 100 divided by 22, that's at 4.545. And then I divide that by the log of 2. That's the change of base. So it should give me the same answer, divided by log of 2. 2.1844. You can see these two answers are the same. So in other words, how you want to do it on your calculator, on my recording thing, see log of 4.545, that's log of 100 divided by 22 and divided by log of 2. It's hard to see that, but it equals 2.18. Now that's this right here. So I got 2.18 equals 1.6 t. So to make things a little bit trickier, I got t equals 2.18 divided by 1.6. So I divide that by 1.6. 1.365. 365, whatever we're talking about, minutes? Yeah, time in minutes. So after 1.3 minutes, our coffee, that's cooking coffee for quite a long time. Usually I, go about half a minute. So that's going to get the coffee up to 100 degrees. And 100 degrees Celsius is boiling. All right, that was kind of a long explanation, I know, but hopefully you saw two main things is this log, changing the log base to figure out what t is, and then also changing the log when you have a log base of something other than 10 to do formulas 1 and 2 on our formula sheet. All right, last one. Jaden's account will be worth $26.99.40 in a half of a year. The current value is $2,600. So it's another one where we need to find the rate. So it's real similar to that question a couple of problems ago with the depreciation, where you had to figure out the rate and then figure it out what it's going to be after 5 years. So what we have is in a half of a year, $26.99, our new amount, $26.99.4 is equal to $2,600, and I always remember this one as PERT, P E to the R times T. That's principal, your starting amount. E is the number on our calculator. Rate times the time. 2,600 E to the rate, which we don't know, and it's after half of a year, 0.5 time. So they can take a fairly complicated problem and turn it into much more complicated. So divide by 2600, divide by 2600, and we get 1.038 equals e to the rate times the time, 0.5. So log a to the b equals c. So this is log base e of 1.038 equals the rate times 0.5. And log base e is natural log, ln, of 1.038. So we don't even have to do that change of base. Otherwise, you could do log of 1.038 divided by the log of e. Natural log equals I'm going to put the 0.5r like this. So we'll divide by 0.5 when we're done, or multiply by 2 is the same thing. So on our calculator, we have natural log of 1.038. And just to show you, log of 1.038 divided by the log of, the number e is above the division sign, second e. And e is about equal to, it's a little less than 3. It's kind of a number like pi. And as you can see, 0.3, I did something wrong. 1.038, 1.038. I'm going to pause for a second, figure out what I did, and then I'll come back. Okay, I see what I did. If you notice, here's the natural log of 1.038 is 0.037. What I did is I did log of 1.038, and then I divided by, anyway, I did the log of the whole thing divided by, but you got to do log divided by log. So log of this divided by the log of e. If I scrolled up, you can see I have a double parenthesis there. I didn't need that. So I took the log of this whole thing, log of a log. And that's why I ended up with such a weird number. But you get the same number, 0.037. So 0.037 equals 0.5r. And like I say, you can multiply by 2 or divide by 0.5, and we get e, or r is equal to 0.075. And I know that comes out to 0.074 when you multiply that by 2, but I worked it out without rounding, and it was 0.075. Now, if you did 0.74 on a multiple choice, you're going to be able to tell which one is the right answer. And then it says, so you figure that all out, and you're still not done. All we did is figure out our rate, 7.5%. What's it worth in 5 years? So we started with 2,600. 2,600. 2,600. Compounded continuously, so PE to the rate, now we know, is 0.075 times t, which is 5 years. 2,600, the number e, exponent. Now, if you're using the older calculator, do this 0.075 times 5 in parentheses. And I'll do that just to show you what I'm 0.075 times 5. Or work that out ahead of time and not use exponents. I don't, on this calculator, have to do that because it's this is all up there in the exponent. But on the older calculators, it just does one number in the exponent. So his account will be worth $3,782.98. And that's it. I know some of these questions get pretty tough, but that'll get us through the first half, and then we'll do another video on the second half next week.